Hey guys, so I've been doing some practice welding. I didn't figure there was anything worth showing on video, but I was practicing with the TIG welder. I never had good luck with the MIG. I did all the panels on the blue truck with the MIG, and never was particularly happy with it. And now that I got the TIG welder, well, I've had it for a few years because it was quite a few years ago that I actually did the cab on that truck. But I was doing some various tests here. This was a fusion weld, no filler, same here. And I found that that was interesting because you got a fairly low top to it because you weren't adding any filler to it. But I found it was really intolerant of any gap. Like if there's any gap, you blew through instantly. Then I went and I was trying some thin welding wire. This was with some 24 thou MIG wire, and I found that that worked okay. You got like a decent sized bead, and you got okay penetration. But I also found that that would blow through pretty easy as well. So I went and I bumped up to my 16th inch TIG wire, like proper TIG wire, and tried that. And you could do that fairly well. You got a fairly thick and good, decent penetration. This isn't a very good example of weld. I got some better ones that I did today with that one. And I think the reason why the thicker wire, the 16th inch wire, worked better than say the 35 thou, which I was doing today a bit of, was because it was quenching it. But I actually had pretty good results with the 35 thou MIG wire, which I think is what I'll use, because I started out today doing some welds again. It got some decent penetration. It doesn't look great from the backside, but it's full penetration. And that was with 35 thou wire that I was doing that one there. And so it's not as mounded a weld as that one is, but it's a lot lower profile and still gets full penetration there. It is a lot more sensitive to blowing through, as you can see there. I blew through at that end and at that end as well, but the edges are always hard. Then I went and I was, this one was probably my more successful one here, and that was with, once again with 35 thou again. This is hammered and dollied flat, and decent penetration there. Like it looks pretty good there. I think I'd be satisfied with that if I do that on my panels that I'm doing into the car. This is 22 gauge steel here, or 32 thou or something like that, 35 thou, somewhere in that range. And it seems to be pretty good. No blow throughs there on that one. And lastly, I wanted to see what would happen. These are all butted up tight against each other, those ones. But this one was with a gap that you would see with these panel clamps that are supposed to be for MIG welding. They always do say that when you're doing TIG that they should be as tight together as possible. And I actually found that I could do it with that much of a gap between it if I used the thick wire. Otherwise I couldn't get enough wire in there fast enough before it would blow through around it. So we'll see how we go here. So I got some plans, like for anything that I can get fitted tightly against each other, I'll use the 35 thou. But for anything where there's a gap, like a significant gap like that, and I can't back it with a piece of copper, I'll use the like the 16th inch, which is like 62 thou, 62 and a half thou, which is actually quite thick. I think the rule of thumb for at least for MIG welding is that you should use a wire that's pretty similar in thickness to the panels that you're welding. Now obviously that doesn't apply when you're welding thicker stuff than like 35 thou, but nevertheless, like that's what the rule of thumb that I had heard. I also did some tests with some spot welds. I punched some, what were they, 1/4 inch holes in here, and then welded it together. And I found that the 35 thou wire just didn't work. I couldn't put enough metal into it quickly enough before I'd melt all the surrounding metal around it. And I had to use, once again, the 16th inch wire for that. But it looks like it turned out okay. You can see I didn't have it clamped tight enough when I welded it together, so at the ends it wasn't great. But I'll when I actually have to do some spot welds, I'll do it differently. I might try some grinding on this. I don't know if I will or I won't. I want to see how much, what it looks like when it's metal or when it's finished. Might be worth trying. I don't know if it's worth trying on that piece. Like on the fusion welds, that's the problem with the fusion welds, is you don't get any extra material. So you know, any pits like right there, if you can see it, aren't going to go away with any measure of metal finishing or any measure of finishing on it. You can see some pitting on the backside. So I don't think that fusion welding is a practical way to weld in any metal panels. Like I said, it's kind of fussy. But both those two turned out well. You know, like I said, 16th inch on that one with a gap, 35 thou wire with no gap. So what I'm going to do is there's my template cut out over there, and I'll cut out a piece as oversized, and then I'll use a scriber to mark it, and I'll very, very precisely cut it with my sheet metal cutters, and we'll try and weld that in. But I don't think I'll do that today. Mennonites are baling hay today, and I kind of feel guilty not helping them. Anyways, apart from that, I think that's probably it for today. A couple of things that I wanted to talk about, since we're talking about welding anyways. I was always told when you're MIG welding sheet metal panels that you should let it naturally cool. You shouldn't air dry it, you shouldn't quench it with a wet rag like I've seen some of the guys doing. And I didn't want to say anything about it because I don't have personally enough welding experience to be able to comment on that in an educated manner, but I did get some confirmation from Welding Tips and Tricks. He said that with carbon steel, yes, quenching it with a wet rag, rapid cooling it, you are hardening the weld. So it's probably not the best idea. I know that it makes it go a lot slower, but like the concern that I had heard about with hardening the MIG weld is that if you go back and you hammer and dolly that weld, it's going to crack. So just something, food for thought. Like I did do some hammer and dollying on this piece here, and that was just with MIG wire with the TIG welder, and TIG welds are supposed to be fairly soft, and I had no problems. You can see it did actually flatten out the weld a fair bit, and I did manage to get any of the warpage out of it by hammer and dollying it. So that's just for your own reference. I don't know what else I could say other than that. Okay, back again. Did a little bit of grinding, and I thought I'd show you the results of it. It's really hard to grind the spot weld, so they didn't end up turning out too well, and you can see I overheated at that spot and actually ground it significantly thinner. So that's one of those things that I have to be a lot more careful with. I shouldn't say grind. I was using a flap disc, but essentially it's the same thing. Okay, results. Fusion weld. Boy, it took like about 2 seconds to flap disc that out, and you can see it worked pretty well. There's a little bit of pitting in there, but not pitting, I suppose, but voids. And same again on the other side. Turned out pretty well. There you can see the reference for the unground one. Then this one was the 16th inch TIG wire that I was using, or TIG rod that I was using. Because it built it up a fair bit, it was really easy to overheat this when I was grinding it, because there was a lot more to grind out. It also, I can't say I had exactly a satisfactory results. It was very hard to grind it, and actually the buildup is so high I was reluctant to grind it a lot more. Now, a little bit of warp in there from grinding it, not too bad. Now here's the one that I did. That was the one with the gap, and this is the one with no gap with the 35 thou MIG wire, solid MIG wire, I should say. And that turned out not too bad. This is actually the back side. The top side actually didn't look as well. It was a lot of the same thing as what I saw with the MIG, or sorry, with the actual thick TIG wire. This thin MIG wire was a little bit harder to grind out on the top, but the warpage was a lot less because like I didn't put as much heat into it when I was grinding it. So, that's my experience there with this stuff here, guys. Hopefully this is giving you guys some ideas here. Or not. Or hopefully it was entertaining. Anyways, guys, that is it for today.